guys, this is Erica and I'm going to be showing you how to do number 53 on chapter 4 of the Physics C textbook. Alright, so let's read the problem. The problem reads, your grandfather is co-pilot of a bomber flying horizontally over level terrain with a speed of 275 meters per second relative to the ground at an altitude of 3,000 meters. Part A. The bombardier releases one bomb. How far will the bomb travel horizontally between its release and its impact on the ground? Ignore the effects of air resistance. Part B. Firing from the people on the ground suddenly incapacitates the bombardier before he can call bombs away. Consequently, the pilot maintains the plane's original course, altitude, and speed through a storm of flash. Where will the plane be when the bomb hits the ground? Part C. The plane has a telescopic bomb sight set so that the bomb hits the target seen in the sight at the moment of release. At what angle from the vertical was the bomb sight set? Alright, so the first thing we want to do is we want to list all the information and draw a picture so that we know what we're going to be doing. Let's move the textbook. Alright, so the first thing we're going to do is draw a picture. So, this is going to be our plane, our bomber. I apologize for the horrible drawing. And this is going to be the ground. And then this will be our little bomb here, going down on this path. So we know that the height from the problem is 3,000 meters. And we're going to set the height equal to 0 where the bomber is. We also know that the velocity, horizontal velocity, is 275 meters per second. We're going to set the up version plus y and the going horizontal plus x in that direction. So part A asks us, let's list all the information first. So we list all the information as x and y, so horizontal and vertical. We want to know if we know initial velocity, final velocity, acceleration, time, and change in x. So we know that this is 275 meters per second. This is also 275 meters per second because it doesn't say in the problem whether they're going to stop suddenly moving horizontally and drop dead to the ground. And we know they're not moving anywhere, so this is 0 meters per second. They might land. And then acceleration downwards is negative 9.8 meters per second squared. And then this is going to be 0 meters per second squared, since we're not including air resistance and such things like that. We don't know the time for either the horizontal or the vertical direction, but we do know that they're going to be equal to each other. We also don't know what the horizontal distance is going to be, but we know that the vertical distance is negative 3,000 meters, since we set height equal to 0 up 3,000 compared to the ground. Okay, so part A of the question asks us to find the horizontal distance. So this is going to be the change in x, which is what we're trying to find. In order to find this, we need to know what the time is. So we're going to use the kinematic equation that says change in y equals initial velocity times time plus 1/2 at squared. And then if you plug in all the numbers, that's going to be negative 3,000 meters equals 0t plus 1/2 negative 9.8 t squared. And if you solve that, it's going to be t equals approximately 24.74 seconds. Alright, so using the 24.74 seconds, since we know that the time it takes for the bomb to go to the ground as well as going horizontal distance is going to be the same, we're going to use that to solve our next part. We know that distance equals rate times time, right? So if we plug in numbers, the rate is 275 meters per second, and the time is approximately 24.74 seconds. And you multiply those together, you get approximately 6,804.485 meters. Since this is a big number, it's just more convenient if you turn it into kilometers. So if you approximate into kilometers, it's going to be around 6.80 kilometers. And that's going to be our answer for part A. Yay! Alright, so part B asks us where will the plane be when the bomb lands if it keeps going straight. The reason why I asked us to do so is normally bombers, they turn a different direction to try to avoid being damaged by the bomb that is going to explode later. So, but in this case, it does not go, turn, so it's just going straight, so the plane's going to keep on going this way all the entire time. And since the plane and the bomb are traveling the same speed in the horizontal direction, they're going to be at the same place no matter what until the bomb lands. But the height we know is always going to be 0 to 3,000 meters. The bomb is going to land on the ground, which is negative 3,000, and then the plane is going to be at 3,000 up high, which is what we set at 0. So in relationships to each other, the plane will be 3,000 meters above the bomb. Since 3,000 is once again kind of a big number, we're going to change that into kilometers, which is approximately 3 kilometers. And so that's what the distance vertically is going to be because there is no change in difference horizontally. Alright, so now we're going to go on to part C. So part C asks us to find the angle in which the bomb was launched. So essentially we're trying to find this angle right here. And so let's draw another little picture to make it easier for us to understand. So we know that this is going to be the plane. It's going to be a square plane. And if we draw a triangle, because triangles are easy to deal with, this is going to be 6.80 kilometers approximately, as we found in part A. And this is going to be 3.0 kilometers. This is going to be where the target bomb place is. Since this angle essentially is the same thing as this angle, we should know that from geometry. We can just solve for this angle and figure out what this is. So we can say tangent, which is opposite over adjacent. So 6.80 kilometers over 3.0 kilometers is going to be our answer. So tangent theta, we'll name this theta, equals 3.0 kilometers or 0.6, no, opposite. So 6.8 kilometers over 3.0 kilometers, which is going to be theta equals inverse tangent 6.8 kilometers over 3.0 kilometers. And if you plug that into your calculator, we are going to get the fabulous answer of approximately 66.2 degrees, which is going to be our final answer. And now we've solved all 3 parts of the problem. Wonderful! Have a nice day, guys!